welcome to GCSE Maths Help. Today we're going to be looking at algebraic proof and the key points you need to know for your exam. Let's get started. We can use algebra as reasoning to prove that certain statements are true or false. For example, if you times three consecutive numbers together, the answer will always be even. Or if you times a number by 20, it'll always be a multiple of 2. It's a little bit like working out a hypothetical situation, but with algebra in it. For example, show that 3 divided by x plus 2 plus 9 divided by x squared plus x minus 2 is equal to 3 divided by x minus 1. So looking at this question, we've got two fractions on one side, but only one fraction on the other side. So we're going to have to add the fractions together. And we know from our fractions knowledge that to add fractions together, the bottom numbers need to be the same. But looking at these fractions, it's a little bit difficult to know what to times one of them by to make the bottom numbers the same. So I'm going to start by factorising the quadratic fraction. So we've got 3 divided by x plus 2 plus 9 divided by, and then we want two numbers that times together to make minus 2 but add together to make 1. So we've got x plus 2 in one bracket and x minus 1 in the other bracket. So now we can see some similarities between the two fractions. So I'm going to take the first fraction and times both top and bottom by x minus 1 so that the bottom numbers are going to be the same. So we've got 3 times x minus 1 divided by x plus 2 times x minus 1. Add together with 9 divided by x plus 2 times x minus 1. So now the numbers at the bottoms of the fractions are the same, we can add them together. So that's going to give us all together 3x minus 3 plus 9 divided by x plus 2 and x minus 1. So when we tidy that up, we get 3x plus 6 divided by x plus 2 times x minus 1. So now we're going to factorise the top bit. We can take 3 out as a factor. So we've got 3 x plus 2 on the top divided by x plus 2 times x minus 1. So now because we've got a bracket on the top and the bottom of the fraction of x plus 2, we can cancel those out because anything times x plus 2 divided by x plus 2 is the number it started at. And that gives us 3 divided by x minus 1, which was the fraction that we were aiming for. Often in algebraic proof questions, you will have to form the expression needed to prove or disprove the statement. A common one is thinking about what happens to 3 consecutive numbers, so it's worth remembering that those 3 numbers can be expressed as n plus 1 and n plus 2. For example, prove that the sum of the squares of any 3 consecutive numbers is 1 less than a multiple of 3. So the 3 consecutive numbers we're going to use are n plus 1 and n plus 2. So the sum of the squares of these numbers are going to be n squared plus n plus 1 squared plus n plus 2 squared. So if we multiply all of that out, we get n squared plus, and then n squared plus 1n plus 1n plus 1. And then the other brackets multiplied out are n squared plus 2n plus 2n plus 4. So if we gather up our like terms here, we've got 3 lots of n squared, we've got 6n, and we've got plus 5 at the end. So if we wanted to take out a multiple of 3, we could take out 3 n squared plus 2n plus 1 and then have 2 left over from our 5. So that shows that the sum of the squares of 3 consecutive numbers is always 1 less than a multiple of 3 because our 2 at the end is 1 less than 3. These types of questions are really hard, there's no two ways about it. At least in the first question we did, it gave you the answer that you were aiming to get to. But when you don't have that, like in this question here, think logically, Think calmly and read the question carefully because all of the clues were there for us. We know now that 3 consecutive numbers are n, n plus 1 and n plus 2. And we knew that at the end we were looking for a multiple of 3 to take out as a factor because the question told us that. So take all the clues you can from the questions with these algebraic proof ones. I really hope you found this video helpful. If you'd like to have some practice at answering exam-style questions on this topic, click the link in the bio below. Don't forget to subscribe to GCSE Maths Help with the subscribe button below, or you can check out my Instagram page at GCSE Maths Help for more videos and tips. Thanks for watching.